Today, we are going to be looking at how to resolve integration by parts in integration calculus. So, I welcome you all to another great section of this tutorial class. And please ensure you watch this video to the end and don't skip any part of this video. Ensure you don't skip any part of this video. You have opportunity to watch this video over and over again to ensure you get the full detailed explanation we're trying to render in this hour and class. So let's go to what we have for today. Now the definition is, if you have integral u dv, the answer will be uv minus integral v du. Now what is the meaning of this? We are talking about when we have two product functions, like we have a product function or two dissimilar functions multiply each other. How to integrate it? How to integrate two dissimilar functions? That's what we are looking at in this section. That's what we're trying to look at in this section. So now there's a problem here. This is a product function, just like you have product through integration, but this u cannot be choosing anyhow. This u and the v cannot be choosing anyhow. So how do we choose u? How do we choose the v? Now look at the order of choosing u. Order of choosing u. If you see a question and you want to choose your u, the first question you take, you choose as a u. Number one is a logarithm, natural logarithm function, or you write it this way in x. These are the first functions you're going to take as a u. Now, if these functions are not present in the question, number two, the next one you repeat as a u should be a polynomial function. A polynomial function. That is the second function you can take as a u. That is the second function you can take as a u. Now, if a polynomial function is not present, this is not present, then number three, you can pick an exponential function. And pick an exponential function. Now, if exponential function is not there, maybe everything there, they are just three functions. You can use trig rule or trigonometric rule to resolve the problem. So these are the functions you do take as a u. This first, if this is not present, you take this. If it's not present, you take this. Let's look at a typical example. Let's say example 1. Integrate x exponential x to dx. That's the first thing. So what our u here now? Our u should be, this is not present, but this is there. Our s is our u. Then if you differentiate this, you are going to have 1 with respect to x. That's what we're going to have. Then our dv will not be equal to exponential x dx. This exponential x dx, that will be our dv. The remaining part will be our dv. So if you integrate both sides, this one will become v. Then if you integrate this one, you're going to have exponential s. The thing will not change. That's what we're going to have. Now apply this formula. We're going to have uv. Our u is x, v is exponential x, minus integral v du. V is exponential s, du is 1 dx. That's what we're having. The next thing, we'll have x exponential x minus, what is the integral exponential x dx? Because this one, if you multiply it, it will still remain the same. Integrate exponential x to x, it will still remain exponential x, then plus c. That will be the final answer to that. As far as you know what you are doing, you don't have much problems. You don't have much problems as far as you know what you are actually looking at. So the next thing, let's check. Exponential is common to both sides. I'm moving out, x will be left here. Now what is the question of this one? 1. So plus. This will be the final answer. Let's look at another problem. Say example 2. Let's say we are having s squared log x to base e to dx. Let's say we have this problem and want to resolve the issue. Let's say we want to resolve this issue. Now, want to resolve this issue, our u here should be choosing accordingly. If you choose s as our u here, the issue will not be resolved. So what do? You choose the appropriate u. What's our u here? This should be the first thing we're choosing as u. So it's present here. Our u should be log x to base e. That will be our u. And if you differentiate this one, you give 1 over x dx. That's what we have. Now our dv will not be x squared dx. So if you integrate both sides, we're going to have something like this. We'll be having v to be equal to s raised to power 3 over 3. Remember, I've showed you guys how to integrate polynomial function. You add 1 to this power and divide everything by that same power. That's how to integrate polynomial function. So we add 1 to 2, we're going to have 3 divided by that same thing. That's how you integrate polynomial function. The next, apply this formula, you have uv, what is u? Log x to be c. What is v? S squared. Then minus integral v dg. What is v? What is v? uv. Okay, what is v now? V is okay. What is v? What is v? Our v is s cubed over 3. Our v is s cubed over 3. That's our v. uv. Our v is s cubed over 3. And s cubed over 3. What is the u? 1 over x dx. That's what we are having it. That's what we are having it. So h says I cancel this one, that will be 2. So we have it like s cubed over 3 log x to this e and minus 1 over 3 will come out to our s squared dx. So you see we have just one term there to integrate. So let's integrate this and see what we're going to have. We'll be having s cubed over 3 log x to this e minus integrate s squared. That's 1 over 3. Integrate s squared, we'll have s cubed over 3 then plus c. That's what we'll have. So this will give us s cubed over 3 log x to base e minus. Okay, if you check it very well, you check this very well so that we don't expand the bracket and have a little issue later. S cubed over 3, s cubed over 3, they are common to both sides. Don't move them out. Now I have s cubed over 3, then log x to this e will be left there. 1 over 3 will be left this other side. So this and this will come out. This is what you're going to have in this other side. So let's look at, let's have example 3. This will have example 3. We have example 3 log number 3. Let's integrate a trig function now. Let's say we have integral x sine x to ds. Let's see if we want to integrate this one now to see what we are going to have. So for this case now, our u will be x. The u will be 1. If you differentiate x, you are going to have 1 with respect to x. Then our v will now be, when you integrate this other side, that will be v. Integral sine x dx. That will be v. That will be minus cos x. Minus cos x. So if you integrate sine x, you have minus cos x. That's what you are going to have. The next thing, apply this formula. You have uv. What is u? X. What is v minus cos x? Minus integral v dg. What is minus cos x times 1 dx. That's what we're going to be having. Plus minus x cos x plus integrate cos x, you're going to have sine, another time cos integrate cos x, you're going to have sine x plus c. So you're going to have minus cos x plus sine x plus c. That's what you're having as our answer to that. That's what we have. So first thing, you're going to choose your v, differentiate the v, then integrate this other one to get, choose your u, then differentiate the u, integrate this other one to get your v, infuse into this formula. You have this. Now that's not plus plus. This one is already out. Integrate this cos, but they say you integrate this. The minus is already out. Because you are going to have sine. Integrate cos, you are going to have sine. That's what you are going to have. Now, let me teach you guys a little tricks. A little trick on this integration by part. A little trick on this integration or in this integration by part. What is integration by part? With little tricks. Let's see what we have. Let's see what we have. Now, the first trick we are going to look at. First trick we're going to look at is how to resolve integration by parts that involves a polynomial and exponential. That involve polynomial and exponential. The trick is going to work for this. The trick will still work for this. A polynomial and a trig. That because of sine, cos and sine. Also work for this, and let me just put it there. Polynomial and cos also work for this. So the trick do works for this and this polynomial and sine, polynomial exponential. But for a logarithmic function and polynomial, it might not work. We're going to develop another trick for that. Then for an exponential function and a trig function will not still work. It only work for these three. That's what it works for. So how do we do it? Let's say we have a problem number 1. Let me just pick a problem there. Let me pick this one. So let's try it with this first one. X sin x dx. Let's try with this. So the answer to this will be, if we want to use the trig, the first thing you do, you choose your u. This will be our u and this will be our dv. You must know how to choose that one. Then you first of all write everything out. The u remains the same, but the dv you will integrate it. If you integrate sin s, you are going to have what? You write your u out, then ensure you integrate your v. That it was minus cos x. Then the next thing from the formula, remember the next thing is minus. The next one is minus. So after that, you will be differentiating the, you leave the question, come to this one. You'll be differentiating the, let me just write it out the way they are. You'll be differentiating your u and you'll be integrating your v. It's very important that way. You'll be differentiating your u, you'll be integrating your v. Now, differentiate x, you're going to have 1, and you will stop when this polynomial is a constant. It's not a constant number, there's no s again. Differentiate x, you're going to have 1, it's already constant. Then integrate this. If you integrate minus cos s, you're going to have minus sin x. If you integrate minus cos s, you have minus sin s. If you integrate cos s, you have sin s. And since this one is a constant number now, do plus c. So we'll be having x, that's minus cos x. This one times this, that's plus sin x plus c. That's what you're going to be having. But ensure you don't put the bracket, write them out the way they are. Now let's look at another one. Look at another one, that's number 2. You want to look like the s power 2 exponential x dx. Let's look at this and see what we're going to have. So if you do this now, so the first thing, choose your u and dv. This should be our u, so that will be our dv. So write your u out and integrate your dv. Integrate exponential x. You're going to have exponential s. It will not change. It will not change at all. Then the next thing, from the question, we have minus. That's what we have from the formula. We have minus. You can just see this one is already plus. This one is already plus from the beginning. The next one will be minus. The next one I'm going to write on the plus. The sign will also be alternating. That's another thing to get. The sign will also be alternating. This one is plus, so will be minus. The next one, as if there was another one, will be plus. So differentiate this one. We'll be differentiating the u and be integrating the v. Differentiate this one, we're going to have 3s squared. Then integrate this, we're going to have exponential x. The next sign will now be positive. This one is negative, the next one will be positive. Differentiate this, you have 6x. Integrate this, you have exponential. The next one will be negative. Differentiate this, you have 6. Integrate this, you have exponential x. Since this is not a constant number, you get plus. That is the end. So exponential x is common. Move out exponential x. You have s cubed minus 3s squared. Plus 3s squared plus 6x minus 6 plus c. That's what we're going to have as our final answer. So you have the opportunity to review it again, check it again, over and over again to get it properly. So last question for the day. Let's say we have we'll be our example 4, 5, 6 now. So you have exponential and a trig function. Let's say we have like this. Exponential and trig function. Let's say we have solving exponential and trig function. Now there's a way we solve this exponential and trig functions. Please ensure you note the way, because none of them is going to be reduced. You cannot reduce any of them to a constant number, but we can solve them using algebra. So I'm going to finish the problem using algebra. That's how we're going to finish the problem. First, I'm going to choose your u should be exponential s as the last one to choose as u. Since there's no trig and since there's no polynomial, there's no logarithm. So if you differentiate this, you're going to have exponential function dx. Because it will not change. If you differentiate the exponential function, it will still remain the same thing. It will not change. Then the next thing you're going to do here, then your v will be, when you integrate the last one, which is sin x dx, and that will give us minus cos x. That's what we're going to have. So the final stuff will now be integral u dv, that is uv, what is u? Remember the formula is uv minus integral v dv. Remember this. What is u? I'll use exponential x, our v is minus cos x, then minus integral v dv. minus v. What is v? Our v is minus cos x, and our u is what? Our du, not u. Our u is exponential x dx. That's what I have. You still have two terms there. So we're going to have here minus exponential x cos x. That is going to give us plus integral exponential s cos s dx. You see, if you have a problem there, we still have two terms. So if you don't have to integrate this one now, we still repeat integration by part again. So our u there for this second one, our u will still be exponential x, du will still be exponential f ds because the thing will not change, differentiate it. Then our v will now be when you integrate cos x dx, and that will be sine x. So apply the formula for that other part. This one is already free. You have minus exponential s cos x, then plus integral u v minus integral, okay? Times u v dv. This is the formula we are using. So we just go over this, you put the stuff there. So you put the stuffs. Our u here is exponential x, our v is sine x minus integral v is sine x, then du is exponential x dx. That's what I have here. So let's simplify everything. We have minus exponential x plus exponential s cos x, then plus bracket exponential x sine x, then minus integral exponential x sine x dx. That's what I now have. Exponential s sine x dx. Now if you check this very well, it is integral. Check it to integral exponential x sine x ds. Now check the question we are solving. Integral exponential x sine x dx. That's how we have for this case. So we have a trig function and an exponential function. If you integrate twice, you solve problem. If you integrate twice, you go and land up in the question you are coming from. So we are back to our question now. Since we are back to our question, we can resolve this issue using the principle of algebra by making this the subject of the formula. Since the question itself already is like this, so you can just make the question of formula to get an answer. So let's see, let the question be called I. Let's call the question I. So the question itself, we call it I, and the question will solve it. We're having minus exponential x cos x plus exponential x sine x. Then this one now is still like the question, we call it I. So we will have the next thing we have I exponential x cos x. Open the bracket, we have plus exponential x sine x minus I. Next thing, we like things, we now have I. If minus plus this to plus I is equal to exponential s, minus cos s plus exponential s sine x. The next thing, we are going to have 2I is equals to, and can write this one before because this negative sign, so we don't omit it. So we have exponential s sine x, then minus exponential s cos s. We're writing this before this one. Remember to have minus, so we don't omit this stuff. Divided by 2, divided by 2. This one cancels this. The question that so will now be equal to exponential s is common, that's exponential x over 2 sine x minus cos x. That's what we will have as our final answer. So this is how this problem always looks like. You solve it the first time, you have this. If you solve it again, you will go back to the question. Just call your question I and resolve it using this approach to get your answer. It's very simple. So maybe very soon we'll develop a switch formula, though shortcut for this will not be possible. So we are going to also try to develop a shortcut for that. We already have shortcut for these three. So for logarithmic, we still try to develop shortcut for that. So you can watch the video over and over again to ensure you get the full details. So God bless you. See you guys in our next class. Thank you.